The mechanics of creating a confidence interval for a difference of two parameters are no different from the mechanics of creating a confidence interval for a single parameter. We still have our sample statistic, which in this case is p1 hat minus p2 hat, plus or minus a margin of error. We'll calculate our margin of error based on this SE. So we'll do ME equals 2 times SE. So first of all, calculating our margin of error, that would be 2 times 0.049, which gets us 0.098. And then our sample statistic p1 hat minus p2 hat, plus or minus the margin of error, is negative 0.07 plus or minus 0.098. Generally, as far as rounding goes, I find that with a proportion taking the margin of error no more than 1 decimal place farther than your sample statistic, it's acceptable sometimes to round it to the same number of decimal places, given that we were handed this standard error and we really didn't have to make decisions about rounding. I think it's okay to go ahead and just use it as is. But rounding it to the same as the proportion, or if it's a particularly small margin of error, maybe 1 decimal place farther, is reasonable. We can put that into a calculator and get that 0.07, which will make negative, minus 0.098 gets us negative 0.168, and 0.07, which will make negative, and then add 0.098 gets us 0.028. So let's indicate the plausible values. This interval does start from a negative value and end at a positive value, which is how we can tell that it does in fact span 0. So 0 is a plausible value for p1 minus p2. Negative 0.3 is outside the interval, since this starts at something closer to negative 0.1 or negative 0.2. And positive 0.8 is also outside this interval because it is too large. This only goes up to 0.028. So the next question, is it plausible that P1 equals P2? Note that if P1 equals P2, then P1 minus P2, if both of these are the same, this difference would have to equal 0. So sometimes a question will come up like this, and we have to think about what the value of P1 minus P2 would equal in order for these two parameters to equal each other. So we would say yes here because of the fact that 0 was a plausible value in our confidence interval. So let's do this process for a difference of two means now. We have our sample statistic x1 bar minus x2 bar equals negative 2.1. We have a margin of error that we're given. Note the difference in wording. This is not SE, this is ME being explicitly given to us. So we don't multiply it by 2. We're just going to do x1 bar minus x2 bar plus or minus the margin of error is negative 2.1 plus or minus 0.76. And bringing in the calculator again gets us negative 2.86 as our left endpoint and negative 1.34 as our right endpoint. This time we can see that we start and stop with negative values. So this is an entirely negative confidence interval. It does not include 0. So mu1 minus mu2 equals 0 is not a plausible value, and therefore we would answer no to this. And when we're asked, is it plausible that the mean number of hours of sleep per night is the same for all teens and adults living in the US, given that that's the definition of mu1 and mu2, is this mean for teens and for adults, this is really like asking, is mu1 equal to mu2? Which is also like asking, is mu1 minus mu2 equal to 0? So the way we need to answer this is based on the confidence interval. No, it is not plausible, because mu1 minus mu2 equals 0 is not in the interval. In order to indicate which group is higher, we need to figure out which is group 1 and which is group 2. The implication is that we subtracted group 1 minus group 2, and these are listed in the same order that the parameters are listed in. So group 1 would be teens and group 2 would be adults. Since mu1 minus mu2 is entirely negative, that tells us that the mean for the second group is a larger value. Since when we subtract, we know we get some negative value. So we can say that the mean number of hours of sleep per night is higher for adults. So our full answer should include no, that it's not plausible that the number of hours of sleep, the mean number of hours of sleep, is the same for both groups. And the reason for that is that we know that 0 is not in the interval. So this is our justifying our answer. Then for the second question, if not which group is higher, we need to look to see if this difference is entirely negative or entirely positive. And that tells us whether the first parameter or the second parameter is the larger one. Because the interval is entirely negative, we know that mu2 is greater than mu1, which means that the mean number of hours of sleep per night is actually higher for adults than it is for teens. And we will now look at a more complete application, Nintendo and laparoscopic skills. In this experiment, medical residents were divided into treatment groups. Some of them were asked to play on the Nintendo Wii in a particular game over a period of time, and the other treatment group was asked not to play any video games at all. The logic behind this is that the kinds of laparoscopic tools that are used by physicians have an abstraction that's similar to a video game, in that they have some sort of remote control that's working an actual device that's going into a body. And so there was some speculation that maybe that skill would transfer. That skill of playing a particular video game could transfer to using this tool more effectively. So what we find in our summary here is that we had mean improvement times, that's what we're working with, to complete a gallbladder removal simulation task. We had 132.2 seconds for the treatment group and 59.7 seconds for the control group. And we're also given an estimate of the standard error of 25.4. So if we start labeling these, let's call this first one X bar sub T, and this second mean X bar sub control, or C. We can then see that we're a little bit closer to being prepared to apply some of these ideas. This is definitely an experiment. The residents were divided into treatment groups and told to either play video games or not. An observational study to measure the same thing would be to simply observe or ask how much video game playing these residents do, but of course that kind of study would open itself up to some confounding variables because the residents are choosing their video game playing. And it could be that people who like to play video games have some other characteristics also that have stronger effects on the response variable than this game playing. So we are going to find a 95% confidence interval, and we can choose the order of subtraction. It's always kind of nice to have a positive sample statistic, so I'm going to choose X sub T bar minus X sub C bar. And that is 132.2 minus 59.7, which comes out to 72.5. And then my margin of error I need to calculate as 2 times the standard error. So that's going to be 2 times our 25.4, which comes out to be 50.8. So my interval is 72.5 plus or minus 50.8. which gives us an interval from 21.7 to 123.3. This tells us that we believe the video game playing is responsible for between 21.7 seconds and 123.3 seconds of improvement on this particular task. Now, when we come to this question here, is it reasonable to conclude that the Nintendo Wii training caused this difference? That's where we need to reflect on the methodology of the study. This was a randomized experiment. The video game playing was randomly assigned to the subjects, and therefore we can answer yes to this. If it had been the observational study that I described just a moment ago when we were saying that this was an experiment, we would have to answer no to this and back it up with something about the methodology of the study. So we want to answer yes to this and make sure we say something about the methodology of the study, in particular that the explanatory variable was randomly assigned to the subjects. That's why we can conclude causality here when we see that there is a difference.